Hi everyone. So for today's video, I wanted to sort of discuss architectural options that I've been thinking about as far as bring your own model is concerned. I thought it'd be great to have a discussion around this, before all the work gets started. Um, so let's start with the scope for the custom models initiative, right? So in my mind, the scope consists of two parts, which is bring your own model, which is the ability for our customers to bring in their own model, which could be like code llama or stable code or whatever else they have running. And essentially, this also could be their own fine-tuned custom models that they want to use. So that essentially bring your own model. And then the second part of the custom model initiative is actually to allow customers to fine tune the models based on data from GitLab. And so the ability to actually tweak the models based on code patterns that are observed in the repository itself. Right, and this could be open source models like Code Llama or stablecode, but this also could be like the hosted models like Gecko and Bison and Anthropic once those capabilities are enabled by the hosted providers. So that's the scope. So specifically for this video, I wanted to focus on bring your own model. So as far as bring your own model is concerned, in my mind, there are three scenarios. The first is that we want to enable self-managed customers to bring their own model, and these models would be hosted by themselves. This would be self-hosted models running on their infrastructure. The second is really GitLab.com customers who want to self-host their models on their own hardware. And then last is GitLab.com customers who want to host their custom models on GitLab. And the question really is regarding scope. Is that in scope? Are we going to be targeting that use case at all or not? So that's those are the three scenarios which come to my mind. All right. And for the purposes of this, I'm going to ignore scenario three because there's so many questions when it comes to that, right? How do we secure these models? What hosted models will support? Scenario three I think is quite gnarly and quite complex, and perhaps that can be a second iteration. But let's focus on scenario one and two for the purposes of this video discussion. Um, so there are two architectural options in my mind when it comes to bring your own model. Both of them architectural. The differences in the architecture actually is regarding the AI gateway itself. Okay, so let's talk about this. So the IDE talks to GitLab, right? And GitLab talks to AI gateway, and then AI gateway then talks to the custom models, right? So that's the core part of the architecture. And let's talk about how are we going to do these custom models. So one is that I don't think we want to be able to run these models ourselves. So we presume, or I think it's a fair presumption that the customers will be running these models themselves using something like TGI, like Hugging Face TGI, which is generation inference, which is basically a gRPC interface that they provide, and they kind of optimize the running of these models on hardware such as virtual machines or Kubernetes, etc. And then the other is VLLM, which is also very popular. It gives you the ability to run these models again on GPUs, but it also optimizes the way the GPUs are used. It optimizes the KV cache and things like that. So, again, I don't think we are going to replace these technologies, and nor, I think we want to be able to provision VMs because really we don't know what hypervisor they use. They could be using Hyper-V or vCenter, any of these, right? So we don't want to kind of be in the business of provisioning all these different types of infrastructure. That's going to be quite hard for us. So instead, I think the thought is that AI gateway will be configured with a basic gRPC or REST API that will then point to some sort of load balancer, and this could be like Rayserve or TGI or anything else, which will then redirect to the models running on various systems, right? So the idea here is, and between both options, really the idea is that AI gateway talks to these APIs and will configure AI gateway to say, okay, point to this model on this location. Again, just looking it up. So the way it will work is IDE talks to GitLab, and GitLab does a lookup, right, in terms of, hey, which is the AI gateway I should look at? Is it our standard hosted AI gateway that we are using, or is it some sort of custom AI gateway, right? And that will be some sort of configuration at the group or subgroup level to say, hey, look at this AI gateway. And then of course, it goes to the calls go to a gateway, etc. Now in this architectural model versus contrasting it with the second option which I have here, the only difference is the way we talk to AI gateway. One is that the IDEs talk to GitLab and GitLab talks to AI gateway, and the other thing is that IDEs talk directly to AI gateway. So let's talk about why some options are better than the other. So let's talk about this option here, right? One is that a lot of the all our prompt and business logic remains in a monolith in this case, right? When the IDs are talking to GitLab, and it's very similar to the current architecture that we have running today. And the best part about this is it works for all sort of in-app features such as MR summaries, etc., etc. But the one big problem with this is does it work for .com customers, right? If .com customers run AI gateway on their own premises, there's obviously going to be a network partition here, right? This is going to be .com customers running AI gateway themselves, but I'm sure they will not write like internet egress into the AI gateway, right? That just seems so insecure. And so yeah, that's why the second option kind of works out better, is because instead of .com customers, um, instead of the IDEs talking to GitLab and then GitLab talking to AI gateway, they just directly talk to the AI gateway. But that does mean that we'll need to sync a lot of our custom model stuff, a lot of our prompts, etc., into the AI gateway, and perhaps even the vectors in the vector store, right? Okay, so that's basically the two architectural options. Now one of the additional things that I want to quickly talk about is in-app features, right? If we were to go with option 2, I'm not quite sure how in-app features like MR summary or even chat in the GitLab user interface would work, because if you presume there's a network partition here, GitLab will not be able to hit the custom AI gateway. So that may mean that they need to go to hosted AI gateway for some of those features in app versus versus hitting their custom AI gateway, right? So there's some complexities there. All right, so with that, I'll like to go to my proof of concept. So what I've done is I've actually connected AI gateway to some custom models, and let me show you the configuration there. So what I've done is I've introduced, excuse me, I've got a bit of a cold today, but I've introduced 3 configuration parameters. One is that enable custom models, the endpoint for the custom model. So this will essentially point to the load balancer in my previous diagram, right? And then also the prompt template to use for custom models. And now I kept this pretty simple for now. And I've used a fill in the middle prompt template here because custom models do support that, which actually make our lives a lot easier. But we could have different prompt templates depending on whether we're doing code completions or chat and stuff like that. Also, the prompt templates are different for different models, so that's also something to keep in mind. For example, for this is the model for Code Llama, whereas stable code uses this fim prefix suffix kind of way of doing things. And so what I've done is I've made changes to the custom model file. I've added a new support for custom models. So just like we call Anthropic or Vertex today, I've added the ability to call custom models in the AI gateway code. Okay. I think that's all with regards to this. One more thing, that another config parameter, the 2 more config parameters that I was thinking of actually adding here is, one is backend authentication. So we need to figure out how would AI gateway authenticate to the backend servers, right? So what is this authentication mechanism going to look like? So that obviously also needs to be defined. And second is, what is the API contract going to look like, right? Hopefully this should be like a standardized contract that we have. And and luckily, something the VLLM can start up an OpenAI compatible server, and so you can just talk using the OpenAI protocol, or TGI has a standard gRPC interface that you can talk via as well. So we have those options that we can essentially use. Okay, so onto the demo. So I have AI gateway running here. And now I've got a request here, and I'm going to make a request to the code completions endpoint, and I'm going to pass in code llama. So model provider, instead of like anything else, is custom, and model name is code llama. So this is going to go, excuse me, hit the locally running code llama that I have. And then you see it's a completion. It gives me the completion. And the brilliant part is that because I'm using the fill in the middle template, it only gives me the middle part that needs to be filled in, right? So it really makes it easy for me to do that. I can change this as well, and I can change this to like stable code, for example, the model. And if I just do that, you'll see that it'll complete using the stable code model instead. So a bit of a different completion here. Okay, the last thing I want to show you is that I've also enabled streaming support. So we could just add a stream, excuse me, the stream parameter here. And so the stream is set to true. And then if I do that, it'll, oops. You can see it stream results. That's all for this video. Thank you.